I'm not sure if this works, but perhaps you can let me know. Can you check to see if this works? Okay, let's see what happens. I'm not sure if it works, but we'll see how it goes. Sorry about this, folks. I don't know what's changed today. Maybe some network, but we'll see. Okay, so let me go to the screens again. Okay, so we were talking about web clients. Let me quickly go through this again. So this is week 4. We're going to look at JavaScript, servers, and JSON. Today we're going to look at JavaScript, servers, and JSON. And in particular, we're interested in looking at how the protocols work for communication between the clients and the servers. So we know that web clients, like your browsers, they establish connections using the IP address of the server, and that's found using the Internet Protocol, and it uses TCP in order to be able to locate and send all that package of information back and forth between the client and the server and the client. So data are exchanged as text, and the server's job is to find the resource quickly, serve it, and then send it back to the client, and then disconnect. Okay. Usually the servers are in a state of readiness. They wait for the next request, service it, and then wait again. And modern web servers are really capable of much more complex cycles than this, but that's a very fundamental operation. Okay. So you really don't need to know an awful lot about how it all works at a network level for this course, but you do need to know that there's a well-defined language called HTTP, and that is how the servers communicate. It's a protocol. Okay? So you don't need to see or know any of it is really happening, but when you specify a URL, the Uniform Resource Locator, your browser performs all of the protocol handling for you in order to retrieve the document. And that would be the resource would be a much better term, because you're not just looking at documents. It gets that from the server. So some documents are static and some documents are dynamically generated by the server at request time, or they're embedded in server applications also at request time. So that's just something we need to be able to do. So this is an example of a HTTP 1.1 protocol. Okay? It's a communication between a client and a server, and the client is curl. Okay? So the client that's actually talking to the server is curl here. And it's looking for a resource called index.html. So we're using a get request from HTTP. We're getting index.html. We're using HTTP 1.1 as the protocol. And we're trying to find that located on some server called localhost on port 8000. So it's a really good thing to be able to understand how this works and it tells me that the server is able to accept all kinds of requests for all kinds of MIME types or different kinds of documents. And that would be text documents, HTML documents, images, and so forth. So we can see all of this happening using a very simple Linux command called nc for Netcat. We can use our own Apache web server in order to be able to do this work ourselves, of course, but this is nice to be able to do this. Okay, so here we have so this is a sample exchange here to get a document from a server. So one way to do this is to start setting up your own Netcat server by saying start a server that listens, nc-l, on port 8000, and that's fine. And then we use curl to access port 8000 to pick up this file from this. And we can actually create our own document, okay, that we will send back to the user here. So we're telling it what the protocol is at the moment, and we're telling it that that this document was found and it's okay. This is just a language. We're telling it that we're sending a text HTML file back. We're going to use UTF-8 as the character set, and the server is going to be Netcat, and this is the actual HTML document that's sent. So we can set this thing up here, and we can set a simple server that does all this work. Okay, so I can show you how this works. So before I moved to my terminal to be able to look at this and some of those demos. Can maybe you let me know how we're doing on the syncing? Are we okay? I mean, can you hear me? Is it all right? Maybe you might pop it into chat, please. And maybe before we do that, I'll just show you something else. For this lecture as well, I produced an actual set of the notes in addition to the original files. That's great, guys. Thanks for coming back to me on this. So I produced this document with all of the code and a description, which is basically the lecture, but it's a transcript. But all the files are here that you can copy. And of course, all of the files are available as well here when you download it, and it'll be good as well. Okay, so let's have a look at getting a simple server going. So we have a few demos here. Let's look at the directory and see what we have. So here's a very simple index.html file that we have. We want to start running and working with the simple Netcat server that we have. So let's go to our document that I recommend you use, and we can start a server here. Okay? Here, so we'll start this. Here's our server, Netcat. So we copy this command, and you can do this yourself, and we'll start a command. It's running here. So all that's doing here, and just we'll have a quick look at that command by looking at this. I'm just using two tabs here for my terminal. I'm going to look at curl to see what's happening at the local host. Okay, so I'm just going to do this. I'm going to make this request. And probably nothing's happening because we don't have a server sending or doing anything. But really the whole purpose in doing this was to look at the request that came from curl. We can see that it was looking for this document, index.html, on the server from here, and it was using curl to do this. Now nothing's happening because we've not told it to do anything. The server isn't doing anything apart from running and listening on this port. So we would like to have a better kind of server that we can run that will actually serve the documents to us. So let's kill this one and let's start another terminal, another shell. And I'm going to lecture demo slash. We're back in again. So now let's write a better server that actually serves the document back. So we can go back to our little document that we have here, these notes, and we can say, well, let's run this line here. See if we can run this. This line. So now we're going to actually tell the server never to stop, just constantly serve this whenever we request. So we'll go back here, we'll run this. So now we have the servers that's running again, it's Netcat. And this is a command line. This is, this running at the command line. So while it's true, so it'll do this forever, we'll do a cat index of .http and we'll send that back to the service. So let's have a look at the service. So now let's have a look. So index.http was this file here. Let's have a look at this file. Okay, and all it does is it includes all the information about the protocol, and it also includes the HTML document. Typically, you don't do this in a document. You would load a file that has this, and this is handled by the application itself. Okay, so now it's running. So let's talk to the server. And we know it's running because services, and we see that it's running here. We know it's running. We look at the problem. So now let's look at using curl again to pull back the document. So we just go curl. Running on 8000. And we can see that we pull back this document. And all it does is just constantly give you this document back. And it's just we got a request and we printed out the request and we can see the request. So we have the server running here. We're talking to the server here over HTTP, and actually, because it's a web server, we can also do fun things with this. Let me just get rid of this zoom. Sometimes the zoom doesn't behave properly. Accessibility. Zoom. Behaving. Today is not my day for behavior. Today's my day for misbehaving. There we go. Okay, so the server is running here. So because it's a web server, we should be able to look at it with a web browser. So let's look at, and we can see we were able to access this server using our web browser. Okay, so that's really nice to be able to do that. So it's lovely to be able to do this. And I mean, we can do this with a different browser and be able to find it. But the interesting thing is if we go back and we look at the message, this time we can see that the first time we did it is that we had a request here from curl. And the next time the request was made, we were able to pull it from our Mac, Intel Mac. It's telling me everything I need to know about the computer. It's telling me that I was using a version of Safari. It was able to tell me all this stuff about the request that was made to localhost 8000. And this is really interesting because you can see that when your browser talks to the servers and web servers, it's sending them an awful lot of information about the browser. It's telling you about the operating system, the computer you're using, the version you're using, about your computer and the operating system, the kinds of documents, lots and lots of stuff. So it knows then, so servers are able to log requests and understand a little bit more about you and the kind of what's going on. Say if you're a Mac user, well, they'll be able to maybe send you advertisements based around Macs and so forth. So this is how it all hangs together using this HTTP protocol. Okay, so we can kill this again and we'll get rid of this. So let's go back to the screen here. So really what's happening here is that we had produced a very simple web server with software called Netcat. And that's just a computer networking utility for reading and writing to a network using TCP or UDP. It isn't an actual web server. It just is able to talk using this particular protocol. So it's useful to be able to have that. And we were playing with that and be able to do some work. Okay? And you know, you could then we had it doing something here, and then we were able to talk to it. Now we can kill the process afterwards. But it's something that's nice to be able to do. So, you know, if you were clever, really, you could do sneaky things with Netcat. So a lot of the time you don't see them installed by default on computers. So, but if you had Linux running, so if you went to, for example, a machine like a lab machine, for example, you could, in theory, have Netcat running as a background process that is watching for files that are on that computer for the creation of files when somebody logs in. And then you could be at the computer next to it and running a local host, saying have a web server on that particular machine, then move to the next machine, and then use a web browser to be able to download something from that particular machine or to be able to watch what's happening with that machine. Okay? So it's sneaky stuff, you know, and you know, it's very simple penetration testing, penetration work. But Netcat is very, very powerful, and we just use it in a brief way to be able to play with HTTP protocol. You know, you can look up Netcat and see some more information how to do fun things with it if you want. I don't recommend doing that kind of course in classes. Okay, so that's a little bit about that. But that server, we much prefer to have, so we don't control over the server. So we much prefer to be able to write our own in a better way, or use a web server. So this is what we want to look at Node.js. And Node.js is this platform that's built on the Chrome JavaScript runtime environment for some easy building of fast and scalable network applications. Now, Node.js is really, really powerful. We'll see a lot of it as we run through this course, but it allows you to be able to have this runtime environment that executes JavaScript code outside of a browser at the operating system or terminal level. It uses an event-driven, non-blocking I/O model that makes it very lightweight and efficient. It's perfect for data-intensive real-time applications that run across distributed services, and it makes lightweight server development easy sometimes. Students don't always find it easy. It does make life easy for you. Okay? It means we can write server-side code in JavaScript. So we have a JavaScript full stack development. So we can use JavaScript in the front end, JavaScript in the back end, and in the middle, and it's all called a JavaScript full stack developer. And that's why when you see advertisements for jobs looking for full stack developers, you will see this term used a lot. And it means you know how to use JavaScript in the back end, and the server side, and on the front side. And to answer your question, Dean, yes, we will be doing Express, lots and lots of Express.js. It's a great technology. So if you can write JavaScript already, then you can start writing Node.js. There's no DOM, so you don't have to understand that, but you will need to understand the event model. And it's a different event model for the back server side stuff than it is for the client side. So here, what we're trying to do now is create this minimal server with Node.js, a minimal web server, one that works with the HTTP protocol. So creating and playing with Netcat is fun, but it's limited. And Netcat is really meant to be used for other kinds of things anyway. So we look at a better HTTP server, and we're going to use server-side JavaScript using Node.js. And here's a very simple one. And the beauty of this is that Node.js has lots of packages available to you, and we're going to use the HTTP package. So we can create a server with a command as simply as this. Okay, we create a variable, okay, with HTTP variable that uses the HTTP package. So essentially this is a kind of object here. Okay, and then we're going to use a method from this object, okay, the HTTP variable, that has a request object and a response object. And you can think about the request is made by the client and the response is made by the server. So we have a header, which tells you everything is okay. So we write a header and tell it the type of content we're going to work with. We're going to send and write this document that's been generated on the fly. It's not reading a file, it's just returning this file. So really we're sending a response to the client from the server by dynamically writing the code here. And then we're ending the response. And this time we're going to listen on port 9000. And this is how we use this particular HTTP. It's nice. We can look at this. I have it written already, and we can look at it in VS Code as well. So here it is in VS Code. Let's have a look at Zenode here just to So it's easy to see. We have this piece of code here. Let's go back to our terminal and have a look and see if we can find it. So I suspect we're looking for a JS1. So here we have a http.js. So let's cat this just to be sure. Yep, and it's the same program. So now we're going to run this particular service. So we'll run it by doing node, because I've installed Node.js already on my computer. So we'll say node http.js. So now we have a server that's running and listening on port 9000. Not giving any messages. It's exciting, really. And so let's have a new shell so we can talk to it. So now let's have a look at curl, using curl. And curl is a command line browser, really. You know, all it allows you to do is talk to browsers using the command line. So curl, great for testing. And this time we're going to look at 8000 again, and it was running because it's still running. Now look at, that's the Netcat one is still running. We didn't kill that process. Now we look at the 9000, which is the port that we're running. And we can see that this is a simple one that's served by Node.js. So we can actually have two servers. We have many servers all running on separate ports simultaneously. So it's nice to be able to do that. We have our original one, which is running on port 8000 still until we kill it. And we killed the terminal, but we didn't kill the process. And we have this one here. And if we go to our web browser again, we can reload this and see, go to the 9000. It stopped once I did that. And we have this web page that's served by Node.js. Okay, very simple. Now we're not, so what we really want to do, of course, is we want to be able to load files, okay, that are on the actual disk rather than just dynamically generate them. But it's working, so we can kill this server now. It's still working away here quite happily. So we can kill this, you know, I'll Control C and let's kill it. And if I come back to browser and try to load it, we can't see because server. Start the server again, we can access it. So let's look at something a little bit different. So what we would like to do now is actually, you can see the commands for doing this here. I've also got these commands for running what I've just done in this document. So it'll walk you through how to do it all manually and you'll be able to see this. Shouldn't be too difficult. But basically, it's a JavaScript app and it creates a mini web server that just sends a single page called a web page served by Node.js every time that a request is made, regardless of any page that's requested. So the server runs on 9000 port and you actually have to use a library called HTTP, okay, and it's required, and we use the require command to be able to do this, and you can see that in the demo. And you can install all the libraries that you need using the Node Package Manager npm, and HTTP and URL, which you'll see, they come with JS as standard, so you don't need to actually do it, but you can install it. And then if you want to have Node.js installed, you can go to Node, you know, look up, search for Node.js on your web browser, do that. let's look for Node.js, and there's nodejs.org, and you can just download and install it for your Mac or for your Windows or your Linux, whatever. I actually use Homebrew for my Mac setup, so I can do, if you're here, and I can install Homebrew, and I can install Node.js using Homebrew because I prefer Homebrew for my installation. And so it's and I manage all my stuff. Lots of ways to get Node, and do try it yourself. So really what's happening here is that we create this server variable called create server variable, and use that then, use the create server method to be able to create the server. And one of the parameters is this anonymous callback function called here. It's not called anything because it's anonymous, okay? And that has a request and response. And these two parameters are key to the communication between the client and the server. So the callback function then is executed when a request comes to the server. So the function responds by signaling everything is absolutely okay, and then it creates a request object, and we're not actually doing anything with the request. But it has lots of information in there that we can pull out. And you can see that there will be lots of information because the client sends all this information to the server, and all that gets embedded into the request object. And it's very nice, very, very simple, straightforward to use. But we can do better. So let's say we wanted to actually request a page from a server using the URL. So, here I mentioned already that we have this URL package, and we can require this URL package, and we can parse the URL package. So we can parse this URL to extract a page. So, because that information is in the request object that's sent to the browser. And we saw that already earlier in the lecture. Okay? So a package actually is, just as an aside, it's one or more modules or libraries that are grouped or packaged together. They're commonly used by other packages or a project of your own. And Node.js uses a package manager called npm, Node Package Manager. You can file install loads and loads, thousands of packages. So, it's quite good. So if there are modules that belong to packages, you install one like shapes, for example, you get all the rest of them. So it's useful to have. So we now know that we can access the file name, but then we want to be able to load the file from disk if it's on disk. So we can use that using the file system module, and we can require the file system module, and we can read a file, and then it's a callback function here for this. And if the file exists, it will load the file, and if it doesn't exist, then it will throw some error. So you need to have a little bit of work to try to understand how these things happen. But you need to look at the event model, and I give some more examples of this in the short lessons that will follow later this evening. Okay. We also have a reference to UTF-8 in the example down here. So we're converting data to a string, and that's a character encoding scheme, and it allows us to be able to use any Unicode standard code. I'm sure you know about this already. And UTF-8 is the preferred standard for email and web, so we will use that as well. You don't need to change that. So here's my web server. Okay, what it does is it says we're going to have a web server. We're going to understand how to parse URLs, and then we understand how files. And it means that we're going to find the file, read the file. So we're going to send back the text file, okay, text HTML, because that's what the browser like to know. It's called a MIME type, multi-part internet mail extension. So it allows us to tell us the kind of documents that we're sending back and forth. We ask for a document from the client asks a document from the server, and the server then says, yes, you can have the document. And by the way, this document I'm sending back to you has this structure. And then we're able to send that, and it's called a content type. And so we send that content type, and it tells us the information, or it tells us that it wasn't. So that's all we're trying to do here. Look for something on a disk and send it back. So we have this server written as well here, and let me find this for you. So this page is called HTTP page. So we'll run this page. Okay, we'll have a look and make sure that is the correct one using VS Code. So let's have a look at VS Code. Find this here. Okay, let's leave Zen mode here. Have a look at this one. So that's the document. This is the one that we're actually going to run now. Yeah, this is the one we want. It's called HTTP page.js. So let's run this node HTTP page. Yes. And it's running, okay. And we're going to make a request for index.html from this. assuming that it exists. Oh, the page was not found. Okay, so let's see what pages we have on the server. So that's a nice. So there's one called index.html, all right, and there's one called readfile.html. So let's have a look at both of those. So index. Okay, so that was the Netcat one, which wasn't really formatted properly. Now we'll have the read file. Okay, and that's the file that was served by Node.js. So that's quite nice. I see a message there from Quita. Can you use that command prompt to make commands computer to list files? Yeah, I misspelled it. What software is this? What I don't understand what software. I mean, this is Node.js I'm using. This is a terminal, so I can run command lines. This is VS Code that I'm using to edit my files. This is Atom that I'm using just to be able to read markdown files. And the software that we're running is JavaScript on the command line using Node.js. And we can see the files that were requested. I noticed when I was looking earlier, I noticed that, just as a brief aside before we move on to look at some JSON, but I noticed when I was in the directory, I spotted this Teletubbies. Let's have a look at the Teletubbies. Okay, so yeah, so there's this image. And really, I think at one point when I was practicing, I realized that, well, when we're sending data with the server, web servers also send images. So we might be able to edit our document to be able to send images. And we can do that by changing the type here of the file that we're going to send back. So if I request po.jpg, we'll see what happens. It'll be really interesting. See what happens when we request po, because we know it's on the directory in the disk. We know it exists. So we look at po.jpg. Server not running. The server's not running because I killed it here. Okay, so I'll start the server again. Okay, it's running again. And I'll reload this. And we get all this rubbish coming on the screen, okay? And that's so this basically is this web server sending the image as text. And my browser has been told that I'm sending text because I've told it here, look guys, I'm sending you text, and it's trying to interpret the image as text, and of course it's not text. So what we really need to do is change our web server to tell it when it's delivering an image, it needs to say, I'm sending you an image. That way the browser will know that it can actually interpret that image. So let's kill the server again. Kill the server. Let's change this to be image/JPEG and save this. So now the server will be able to find the file, and this time it'll be able to tell it correctly that we're sending an image, and hopefully the browser will be able to display. Start the server again. Let's reload it, and sure enough, we're able to view it. We did nothing apart from tell it the information. So there has to be this exchange between the various clients and servers, so that they know what's happening there. Okay, so this image is now rendering correctly when we request it from our very simple server written in Node.js. Okay, let's kill this, and I think we're done with this piece here. So I think anyway, everything is here. You have to look at this. There's a lot in it, okay, and in order to be able to understand it, but it's at the core of everything that you will do for the rest of the semester. I'm looking at the server side. If the file exists, we return it. If it doesn't, we just say the file doesn't exist, and we can assume there can be an error, or handle it gracefully, or we can just die. But the server-side JavaScript is much the same syntax-wise as the client-side, but instead of manipulating a DOM, we're dealing with a file system, a network, all that kind of stuff. We'll talk to databases. We don't need to write our own servers with this level of detail. I just wanted to show you the power of full-stack development with JavaScript. We will mostly use Apache for most of our stuff early on, for traditional PHP type work, but in most situations we have very specialized services that we need to write ourselves. We will use Node.js. That's the second half of CS230. Yeah, I just wanted to show you just how powerful this is. It's nice. Okay, it's really nice. Okay, we move on to a little bit to do with JSON. Okay, so JSON then, and I'm rushing a little bit because we ended up having this disaster with timing and syncing at the beginning. I know what was happening with the network, but But JSON then stands for JavaScript Object Notation, and it's used to store information in an organized and easy to access manner. JSON offers this human readable collection of data which can be accessed logically. And you can find lots of information about JSON if you go to json.org or click through on this link. So when we exchange data between a browser and a server, we've already seen that the data is exchanged in text format. HTML is just text. JSON is text. And we can convert any JavaScript object to JSON and then send JSON to the server. So objects can also convert any JSON received from a server into a JavaScript object. So this becomes really, really powerful for us when we want to start doing some client-server work. We can have a back-end service that's managing data as JSON. We can wrap it up in a JSON object, serialize or convert it. We use the word serialize it to JSON string, which can be sent over the network to the client who receives it as a string. And then we can automatically, well, not automatically, but I suppose automatically, we can convert that JSON string into a JSON object. Our way of moving data. Very, very powerful. So we can work with the data as JavaScript objects, no complicated parsing and translations. And JSON data usually consists of a collection of structures. There are two kinds, okay? A collection of name-value pairs, and in various languages it's realized as an object, a record, a struct, a dictionary, a hash table, a keyed list, or an associative array. There's lots of names. Or it can be an ordered list of values, and that's just an array, a vector, a list, or a sequence. So don't worry too much about those in terms of its definition. You'll get to understand the differences as we work through lots of examples. Here's a piece of complex data, JSON data. It's fairly complex, okay? Because it's got nested information in here, okay? And it's not a JavaScript object definition, it's a string. Nothing in the data to tell us that it's an object, even though it looks like some JavaScript objects that we might have seen in lectures. Okay? So, it tells me here's a string. It has two chain brackets, first name John, last name Keating, name value pairs. Here's a nested one, phone numbers, which is an array. So in JavaScript, we could have something like var z is equal to x colon y. That's not JSON, okay? That's a JavaScript object. The JSON equivalent of that represented in the JavaScript language would be var z, and single quote, chain bracket x, value y, goes back. Z is an object of type string and not an object in its own right. If you want to actually turn it into a fully fledged JavaScript object, you have to parse it. So you can use a JSON.parse, and that will convert this into an object. Now Z is an object, but it's not JSON. So you have to be very careful about how you work with JSON and how you work with JavaScript objects. You can convert between them. But sometimes people have problems when they realize that I'm trying to do something with this JSON, but actually it's an object. Or I'm trying to do something with this object when it's actually a JSON string. Okay. So, you have to be careful. So you have to also think about the data model that you use. How well that JSON represents the reality, that the actual thing it's trying to represent, and how good. And that's essentially because it becomes a model of something. So here, for example, is a bad data model. Not a good data model, it's a bad data model. Okay, so it's a Star Trek example, and I'm going to look at trying to model and record a crew that are on the Starship, and it's the Starship Enterprise. Okay, so it's not a good model really, because we expect in this model that everyone will have a first name and a last name. So the reason it's not a good model is because, for example, if you're a Star Trek person and you're interested in Star Trek, you'll know that data doesn't have a surname. So it doesn't accurately model. So if we were having constraints that asked us to ensure that everybody must have a first and last name, it doesn't work, because it doesn't really work then. And Worf, for example, has a human surname, but he doesn't use it. And his son, Alexander Lutsenko, does. Worf could also use his Klingon designation, son of Mo, because he's from the House of Martok. But he could also be referred to as Lieutenant Martok, if you want to use Martok as a surname. So somewhere in the universe, Worf might use his adoptive parent's surname as well, unlikely. But and apart from letting you know that I'm a bit of a Star Trek nerd, really what's happening is that when we try to model reality even though the reality, Star Trek isn't a reality, but let's say it is, then there are constraints and the models are not always good, okay? Because when we have data organized, we like to have them neatly. But JSON allows us to be able to have collections of data that aren't neat. If this was a relational database, everything would have to be nice and neat. And your entity relationship model would have to be completely filled correctly. But JSON allows us to be able to do something. So, we might have flexible models, but data modeling is complex. And JSON doesn't solve it, but it does help you describe your data. So as long as you understand, for example, that your data might be different from one element to the next or one record to the next, that's okay then. And JSON is nice. So another way to actually look at this, for example, in this particular model, is we could have taken a starship here, and we could have organized the crew for that particular starship. But the model depends on what you want to do with it. We can navigate through the data structure using dots and brackets. So for example, we could actually pick out the first crew member listed in the crew list. We would say crew 0.rank. And this would be Deanna Troy. So there's lots of things that we can do here. This works fine, but it might not actually represent the model very well. The model might be fine, might not be fine, but it's well-formed JSON. That's all that matters. And of course, I'm not a Trekkie. I do make mistakes. So let's have a quick look at some of the examples then. Okay, so we can look at an example using JSON in a HTML document. So JSON processing using JavaScript in the browser. So here we have a browser. Let me switch to the other side. Oh no, you can still see this. Okay, so if we look at this one here, so we're interested in, we have this section here, this paragraph element, and we have a script, and we have some text that takes this text string, and we're converting it to an object. And then we're parsing this then to be able to write something into this demo tag. And it's client side, but the JSON functions work on the server side as well. So this JSON that parses nice. So we have a string, which looks like JSON. We're parsing it so that it becomes an object, and then we're manipulating the object. And that's mostly the kind of thing that we will do when we. So let's have a quick look at our code. If we can see this indexed Star Trek HTML. Okay, so this is the example here. We load this and file here. And we can see that we were able to say, by parsing the code, okay, we're able to, let's go to the code again. We're able to manipulate it here in some way. And we're able to say that Commander Deanna Troy was the counselor on the USS Enterprise NCC 101E. And that was just by starting off with a piece of JSON, parsing it, converting it to an object, and then parsing the object and writing the contents. So it's quite nice, very powerful and very nice. So here's some server side. So we could look at JSON in the application as well, where we're processing on the server side. So here we're parsing again some text string, and we're able to print out some information on the server side. We're only using one record here, so we don't have the full crew membership inside the array, but we could manipulate that as well. So, and I'm just building a string from the converted object, okay, using it as a reference to properties. And I have some demos that you'll be able to look at bigger data structures, and you'll see them in the later lectures. But let's go back to the command line here, and we have a look at Star Trek.js here. Let's have a look at this. Okay, so here we have a server-side code. Okay. And we're going to write to the console. We're doing essentially the same thing again. We have some text. We're converting it using JSON.parse into an object, and then we're manipulating the object, and then we're writing the object information. I'll do node Star Trek. Let's. And I'm doing something similar. Commander Deanna Troy, the counselor on the user. And this was all done on the server side. Okay? So JavaScript is JavaScript. And the core stuff is the same, the way it processes data is the same, the way all that stuff is the exact same. Lots that you can do on the client server. And we could run and write simple programs now if we wanted that would take something on the server side, that's JSON, merge it up, send it to the client side, and then be able to manipulate it as well. So take an object versus a JSON, send the JSON over the internet, and access it using a HTTP request, and then manipulate it. You can do that nicely and dynamically using Ajax, which we see next week. But there are lots of resources online that you can have a look at. JSON lint is nice. It's an open source project. You can validate and reformat JSON. It's very nice. Have a look at that. There's a JSON editor online. It's a really useful web-based tool. You can edit, view, and format JSON if you like. It displays your data side by side in a nice, clean, clear, editable code editor software. And there's a JSON formatter as well that helps you solve the problem of formatting JSON, so it's easy to read and debug by a human. And I mean, of course, if I load a JSON here, I don't have a JSON. Do I have a JSON? Yeah, here's a JSON file. This was nicely formatted as well by my software. And in fact, you can see I have some software here called Retrek. Okay, and what that does is, again, it uses the file system and it's able to read the JSON that's in this file, parse it, and write something to display. So let's actually run this one. Yeah, I'd forgotten I had this. Nice. Let's have a look at this one. So let's have a look again. So it's retrek.f. Okay, so node read trek. Okay. And it was able to read the information. It was able to produce this again using the exact same code that I use in the browser. And it's able to print out the data that it read from a data structure that's held internally in the document, because it was in a document called crew object. So I was able to read all of the JSON from the file, parse it into this array, and then access the array nicely and quite straightforward. So some concluding remarks. So it uses a standard text-based format, JSON, for representing structured data based on the JavaScript object syntax. It's commonly used for transmitting data in web applications. Okay, it can be displayed in a web page, vice versa. Even though JSON closely resembles JavaScript object literal syntax, it can be used independently from JavaScript. Many programming environments feature the ability to be able to parse and read JSON, so you can use it in whatever, anywhere, JavaScript, Java, wherever. Okay? JSON exists as a string. It's very useful when you want to transmit it over a network. Okay? It has to be converted to a native JavaScript object when you want to access the actual data structure, and that's fairly straightforward because all the languages provide a global JSON object or something that has methods for converting between a string and an object. In our case, Java. Great, thanks for attending today. Quick tour of some fun stuff that you can do with Node.js on the server side, web servers, and it sets the scene for much of what we'll do a little bit later. Okay, we looked at some JSON as well, and you can expand on that. And there'll be more information on this in the later lessons a little bit later. Sorry about the problem with the syncing. I don't know what the network issue was. We ended up restarting. Some of you will have found me, some of you didn't, but I appreciate you coming along. Thanks for your, okay. I'll see you in the labs. Take care. Bye-bye.